Okay guys, so we are going to look at some of these problems here on the worksheet together. We're going to start off by looking at number 4. So when you're doing these kind of problems, if you want to keep it in radical form, the easiest way to approach it is to start from the inside. Don't ever try to do the outside part first. It's just much easier if you start on the inside. So we want to just do it this way. The square root of 25, that's going to be 5. If we have the square root of u to the negative 6, we're just going to have half as many as we used to. It's just like this. If I take the square root of x squared, that's going to be x. If I take the square root of x to the 4th, what's that? X to the 2nd. Okay, because we would have x times x times x times x. We need pairs, so we'd end up with x to the 2nd. So the square root of u to the negative 6 is going to be u to the negative 3, and the square root of v to the 4th is going to be v to the 2nd. So that's the answer to the inside part. But now we still have to cube. So we have to think of 5 cubed. So what's 5 times 5 times 5? So it would be 125. And then what do we do here if we have a power to a power? What's the rule on that? What do we do? Multiply. So that's going to be u to the negative 9. And then here again we have a power to a power, so we have to multiply. Then we just have to simplify. The only thing that's going to change is that we don't want to have negative exponents. The directions say write each expression without using radicals or negative exponents. So this is a negative exponent. The 125 though is not attached to the u. So the 125 would stay on the top. The v doesn't go with the u, so the v to the 6th, that factor stays in the numerator. The only thing that goes to the denominator is the u to the negative 9 becomes u to the positive 9, and that would be your final answer. Questions on that? All right, let's go down now to number 8. Looking at the directions, they say express in simplest radical form. At the end, we want to have this answer in radical form. But it's easiest if we start by putting it in exponential form. Exponential form means that I'm going to rewrite things with exponents. So if you look at this first term, we have the 5th root of 4. But what's another name for 4? 2 to the what? 2 to the 2nd. So 4 is 2 to the 2nd. So I can rewrite this, what I just wrote, instead of writing it as 2 to the 2nd and the 5th root of that, I could actually write it as 2 to the 2/5. Because 2 is my power, powers are up high, 5 is the root, roots are on the ground, so 2 over 5 is the way that can be rewritten. The 5th root of 4 is the same thing as 2 to the 2/5. What about the cube root of 2? How do I rewrite that? 2 to what power? The 1/3, right. 1's the power, 3's the root. And then we have divided by. Now notice how both of these are 2's. So I want to rewrite this so that it also has a base of 2. Okay? Because if I have all the like bases, I can apply my rules. So what's another name for 4? And how would I rewrite this? And then what's the root? So it would be 2 to the 2/15. Okay? So this was just another name for that. We'll kind of get rid of that so it doesn't get confusing. So what do we do if we're multiplying and our bases are alike? What do we do with the exponents? Add them, right? So what do I have to get in order to add those numbers? Common denominator. So I'm going to get 15 as my common denominator. So 5 times 3 is 15, so I have to multiply the top by 3 is 6. 3 times 5 is 15, so I have to multiply the top by 5, and I have to add those two. So these two combined are going to be 2 to the 11/15. And then we have to divide, so that goes on the bottom, by 2 to the 2/15. What's the rule when the bases are alike? What do we do with the exponents? Subtract. So now the base stays the same as the 2. We subtract the exponents, that's 9 over 15. But what does 9 over 15 reduce to? 3/5, so it's really going to be 2 to the 3/5. And now looking at our final answer, simplest radical form. So radical form means I want to put my roots back again. So we're going to have the 5th root of 2 to the 3rd. But what is 2 to the 3rd? 8. So the 5th root of 8 would be the best answer there. Did I lose anyone? Is there any part of that that you kind of need me to go back through what I did? Just quickly, anytime we have a 4, a 2, and a 4, we want to get the like bases. So I rewrote this as 2 to the 2/5, 2 to the 1/3, 2 to the 2/15. And then I just used my rules. Bases alike, add. Then we had to divide by this. Bases alike dividing means to subtract the exponents. All right, now we're going to go down to number 12. When we look at this problem like this, it seems impossible to do it. But if we write it with the rational exponents, then it's pretty easy to do. Becky, how would I write the square root of a to the negative 1? A to what power? Right. A to the negative 1/2 times. What about the next one? Charlie, how would I rewrite that? Right. And then what about this last factor? Mitchell, how would I rewrite that? So now we have like bases. If our bases are alike, what do we do with the exponents? Add them. So we might as well add these two first. 3/4 plus 1/4 is 1 whole. 1 whole minus a half is going to be a to the 1/2. Let's look back up at our directions. Leave answers in exponential form. So exponential form means with exponents, and so there we go. That is an exponential. We're finished. Okay? 14. Look at this one. Looks kind of crazy. But it's really not that bad if you just do the same thing we've been doing. We want to work from the inside out. We want to rewrite so that we can have common bases. So if I think about this, I can't take the cube root of 81. There is no cube root of 81. So instead, I want to rewrite this so that I have a common base with this one. What would be the common base we could get with those two? 3, actually. We can't write this as 9 to a power. This is 9 squared, but that's not 9 to anything. So we're going to get a common base of 3. So what is 81 then? 3 to the what? Everybody? So it's going to be 3 to the 4th, and then we're taking the cube root. So I did this part of it. But then I have to take the 4th root. So now what power am I raising it to? To the 1/4, right? And then at the end, we did the 4th root. Now we have to raise it to the 3rd power. So all of this, 81 was 3 to the 4th, but then I was taking the cube root. Then we had to take the 4th root to the 1/4, and then we had to raise it to the 3rd power. So that's equivalent to that. Now we have to do divided by. How would I rewrite the square root of 27? 3 to the what? 3 to the what? 3 to the 3rd, right? And then what's the root I'm taking? Square root. And then we've got a cube root. So what am I going to put here? To the what? 1/3. So now we want to simplify these. Before we start trying to do any other rules, let's simplify. 4 times 1 times 3. Multiplying all these numbers, because when we have a power to a power to a power, we just multiply. So 4 times 1 is 4, times 3 is 12 on the bottom, 3 times 4 is 12. So what's the exponent going to be with all that? Just 1. So this is just going to be 3 to the 1st divided by, and we have to now multiply these. 3 times 1 is 3, 2 times 3 is 6. What does 3/6 reduce to? 1/2. So now our bases are alike. What do we do with the exponents if we're dividing? Subtract. So what's 1 minus a half? A half. So it's going to be 3 to the 1/2. It says to write it in exponential form, so there's our answer in exponential form. Questions? All right, let's flip over to the back. Looking at number 18. All right, same kind of thing. We want to try to get like bases if we can, or in this case though we just have variables, so that doesn't matter then. We're just going to have to rewrite it. It's going to be 4x to the 1/2 y to the 1/2. It's much easier to work with the fractional exponents than radicals. And the other class, some people were like, why can't we just leave it as radicals? Well, because it doesn't work well. It's very difficult to do that way. Okay, and then on the bottom, we have a power to a power, so what's that going to be? To the what? 8. Then we have divided by. What do we do if we have divided by? What do we have to do? Multiply by the reciprocal. So I have to multiply by, and I have to flip this whole thing over. So y to the -3rd goes to the top, 12 goes to the bottom. Let's go ahead and work with this while we're at it. This is going to be x to the 3/2 and y to the 1/2. All right, so now let's just work with it one at a time. Is there anything that cancels exactly? Does anything on the top match the bottom? What factor matches exactly? Look, y to the 1/2, right? So y to the 1/2 divided by y to the 1/2 is going to be 1. Might as well get rid of those. Okay, so now here's what we have. We have 4x to the 1/2 over, I need to take this to the bottom because it's to make it a positive exponent. And I've got a 12 down there. I've got an x to the 8th. And I've got an x to the 3/2. And I took that y down there too, so y to the 3rd is down there now as well. Just checking it. 4x to the 1/2, y went to the bottom, 12. All right, we're good. Now, where do we have more x's, on top or on bottom? Bottom. So I'm going to subtract and I'm going to keep it on the bottom. So what is 3/2 minus 1/2? 2/2, which is 1, right? So I'm just going to have one x on the bottom. So this is completely gone. And I just have x to the 1st now on the bottom. Now I can also simplify these. I have 4 over 12. What does 4 over 12 reduce to? 1/3. So all I'm going to be left with then is a 1 on the top, a 3 on the bottom. What am I going to have on the bottom as far as the x goes? X to the 9th, y to the 3rd. The ACTs always have some questions like this, like which of the following is equivalent? And it takes a while to do one of those problems, doesn't it? So I want to get you to where you can do it a little bit quicker. So when you're doing your homework, you got to be careful, but you still want to increase your speed. Let's go down to number 24. What have I been saying over and over is the easiest way to do it, to get like what? Bases. Can I rewrite 25 with a base that would have the same base as 125? What would the base be? Sydney? 5. So 5 is going to be our base. 25, another name for it, is 5 squared. Now I still have this exponent. Don't get rid of it. And then we have divided by. Now, I'll work with this in just a minute, but what can I do if I have a power to a power? What can I do with those two numbers? Multiply them, right? So I can just change this whole thing, multiply it out, 2 plus 2 radical 5. Just get rid of it, because I multiplied them. And so now, what's another name for 125? 5 to the what? 3rd. So I have 5 to the 3rd. And then I still have this. All right, so now on the numerator then, I have a power to a power, I have to distribute this out. So I have 5 to the 8 plus 6 radical 5. And on the bottom, I have 5 to the 6 plus 6 radical 5. What do we do when our bases are alike? What do we do with the exponents? Subtract them. So if I subtract them, what am I going to just be left with? 5 squared, isn't it? So all that just goes down to 5 squared, which is 25. The reason that happened is 8 minus 6 is 2. 6 radical 5 minus 6 radical 5 is 0, so we were just left with 2. Okay, and we'll do one more, number 26. Becky, how do I rewrite 27 again? I want to get a base that's the same as this, this, and this. So what kind of base should I use? Base of... So how do I rewrite 27 with a base of 3? Right, so it's going to be 3 to the third, and then we're taking the square root. So Maya, what has to go underneath the 3? 3 to the what? Okay, so we've got that. Caroline, what do I do if I have a power to a power? What do I do with those numbers? Multiply them, good. So I'm going to have 3 to the 2 plus 2 radical 5. Abby, what do I do if I'm dividing? What should I do with this whole thing? Right, so multiply by the reciprocal, so I'm going to flip this over. At the same time, I want to rewrite this 9 so that I have a common base with these. So I'm going to rewrite it as what, Michaela? So I'm going to have 3 squared, but it's still to the radical 5 minus 1. This has to go to the bottom. And Karish, what's another name for radical 3? 3 to the 1/2. Good. All right, so now we've got it into multiplication. We might want to go ahead and distribute this. So we have 3 to the 3/2 times 3 to the 2 radical 5 minus 2 over 3 to the 2 plus 2 radical 5 times 3 to the 1/2. All right, so well, maybe we should start with these. Bases are alike, subtract the exponents. 3/2 minus 1/2 is just going to be 3 on the top, because those subtracted out. Those are gone now. With these, where do we have more, on the top or on the bottom? I should have more on the bottom, but it doesn't matter. Our bases are alike, so let's subtract the exponents. If I do 2 radical 5 minus 2 radical 5, those are going to cancel. But what if I do negative 2 minus 2? What's that going to give us? Right, so it's 3 to the negative 4, and it's going to go on top, because look at the way I subtracted. I did 2 radical 5 minus 2 radical 5, and I did negative 2 minus 2. Wherever I started, that's where it's going to go. I started on the top, so it's going to be on the top. Just watch if I would have started on the bottom. I would have done 2 radical 5 minus 2 radical 5. Then I would have done 2 minus negative 2. What's 2 minus negative 2? Positive 4. I would have had 3 to the 4th on the bottom. Is that the same? Is 3 to the negative 4 on top the same as 3 to the 4th on the bottom? Yeah. So it doesn't matter. Just to be consistent. So what's this going to be then? 3 to the negative 3. Because my bases are alike, we add the exponents when we're multiplying. And so then what's another name for 3 to the negative 3? 1 over 27. And that's going to be our final answer. Okay? Questions? All right, so I want you guys to take the rest of the time in class. I want you to get down to number 29. You can stop there. The rest of those we'll do tomorrow in class. So I put some of the first answers on the board up through 17. So I want you to work each problem, check your answer as you go. Okay, if you start missing a lot, then come up and see me and see if we can get it figured out together. Okay?